My name is Sam. I'm a developer advocate for SEML. And before I was a developer advocate, I was on the core development team for LGTM.com. And I'll speak about why that's important a little bit later when I talk about our experience using TypeScript for this product. I've been writing JavaScript for about 15 years. I started out probably in a similar way to many people in this room. I wanted some cool things to move around pages on websites for my personal website and stuff like that. And it later kind of rolled into my career and inspired me to learn much more about software engineering and computer science and stuff like that. I'm passionate about everything to do with open source, security. I work for a security company. Cryptography, privacy, code quality. I'm super into lighting, like stage lighting. I have a bunch of software projects that work with that. And I'm particularly passionate about TypeScript. Passionate enough, in fact, that I've actually got 2 talks today about TypeScript. This is the first one, and there'll be another one later on that I'll talk about that will be entirely live coding. I thought it was important to mention this in case any of you get the wrong idea. I'll be having some screenshots and some live coding demonstrations today. I really don't like light themes at all, but for the benefit of the projector and so that you can all see it, I'll actually be using light themes today. I actually like my retinas, believe it or not. You can find me on Twitter or GitHub or NPM or basically anywhere with this same handle. And it's also at the bottom of every slide in case you forget. So we're going to be talking about JavaScript today. As most of you in this room are probably aware, JavaScript is quite a popular language, and it has been for a while. It was the primary way to add any sort of client-side behavior or interactions on web pages and web applications for many years. And then in 2009, Ryan Dahl introduced Node.js to us, and that definitely made some waves in the development community. For the first time, it was possible to share code both in the front end and the back end for web applications, which is pretty revolutionary. And with certain NPM modules like Express.js, it became possible for client-side developers for the first time to be able to write server-side code using exactly the same languages that they already know. In 2013, GitHub created Atom Shell. This was a project that allows you to create desktop applications using just Node and Chromium's rendering engine, which meant that you could just use front-end technologies like HTML, CSS, and JavaScript to create fully working desktop applications. And in 2015, it was renamed to be called Electron. And this is used for many different applications that you're probably quite familiar with. Both VS Code and Atom, for example, use it. Slack, Skype, Discord, Signal, a bunch of applications, lots of communication applications, actually. And then in 2015, after React had been out for a little while, Facebook introduced React Native, which allowed users to create, or developers to create applications for mobile, like native mobile applications, using exactly the same technologies, HTML, CSS, and JavaScript. So if we look at the number of packages available in different package managers over the years, there's one line in particular that stands out, and that is the number of packages available on NPM, JavaScript's package registry. There are now over 1 million packages publicly available for you to install and use in your applications, which is almost 4 times as much as the next largest repository of packages, which is Maven. So it's probably no surprise that GitHub, in the 2018 State of the Octaverse report, listed JavaScript as the most popular language on their platform since 2014. And I doubt that it's going to be any different this year. It makes sense now that so many coding bootcamps and learn-to-code programs are using JavaScript as the language of choice to teach people, because you can learn JavaScript and then you get transferable skills that you can apply in all those different contexts I listed previously. You'll also notice here at the bottom right corner of the graph, we have a new entry, TypeScript. I'll talk a little bit more about that in a short minute. So we're getting larger and larger JavaScript applications being built now that you can write them in many different contexts. But it can be quite hard to ensure that every single part of a JavaScript application is interacting and behaving in the right way with respect to every other part of an application. How do you ensure that functions are being called correctly, that the right modules are being imported, that the right arguments are being sent to functions, and that you're referring to properties that actually exist and they're of the type that you expect? Certain things like refactoring can be particularly difficult. What happens if you want to rename a file or rename a function or change the sort of properties that you expect to receive from arguments to a function? Making those sort of, having guarantees that that you've changed everything that references that code can be quite difficult. And in particular, when you have a larger team and many people working on the same code base, you might want to make a refactor, and then someone else is introducing new code that uses the code that you're refactoring. Their code lands first, and then yours does, but you are working off of an older version of the code base. So how do you ensure that everything is resolved and everything works? And you might not even know until you deploy to production. So I'm going to illustrate this with an example that I'll be using throughout the rest of the presentation here. So in this application that we'll be talking about, there is a generic class called broadcaster, which is used to send messages around the application. So it has the functionality where you can add a listener so that you can receive notifications effectively or receive events when messages are being sent. And it has a method to send messages to each of the listeners that are registered. Now, this is designed to be used for many different types of messages. We have some model code that effectively describes notifications in the application, notifications that we want to send to the user. And you can see on line 3 here that it initiates or initializes a new broadcaster class that it then uses for this functionality. And there's an example call later on that actually sends a message out. And then we have some view code that's in a completely different part of the application that listens to notifications and then prints out messages to the console. But it, of course, could do something else like add some front-end notifications in a client-side application or something like that. So say, for example, we wanted to rename this function. How do we ensure that we have referred to it in the correct place and everywhere that we actually use the old function? You could maybe do a quick text search, find and replace, but perhaps the reason that we're changing this function to begin with is because we're already using the name broadcast message in way too many places for different reasons, and we actually want to use something different so we can more easily find, do sort of text searches for other reasons. You might do a grep or something for broadcast message and find thousands of results that are irrelevant because they're being used in other parts of the code base. And you might miss one of these instances. Or perhaps that we had a typo when we were setting the property for a message. Maybe we set goo instead of foo. F and G are next to each other on the keyboard. You can look at your laptop if you're unsure or uncertain. This sort of mistake I know that I certainly have typed goo before whilst creating demo applications. And then you might, for whatever reason, have forgotten to send an argument entirely. Another modification you might make, for example, is requiring a new argument in a function, and you need to make sure that you send those new arguments with every existing call to that function. But so that's a good reason why you might have a missing argument. And then, of course, when you're referring to properties, you might also make similar sorts of mistakes. Foo or goo might not exist, or you might change the name of a property, that sort of thing. So a lot of you are probably quite familiar with these sorts of error messages. And anyone that's worked on a medium to large scale JavaScript application has probably debugged this debugged at a runtime, either on some demo instance or dev instance, or sometimes in production. If we're lucky, we get nice big red error messages in our console, but sometimes JS will kind of limp on and continue and try and make the best of the information that it has. The problem can manifest somewhere completely different to where the mistake was actually made, sometimes causing unexpected, weird, or even dangerous behavior. But if we're lucky, we might get an error message in a completely different file. So we can actually save ourselves from a lot of pain that this sort of thing causes. And anyone that raised their hand saying they already write TypeScript will be familiar with the sort of benefit that we get from this. So the basic idea is we want to catch these sort of bugs while we're writing the code before we actually deploy anything. We get told right in our editor what's going on. And that might sound like a lot of extra work. Like, is this radically different development to normal JavaScript development? Well, to be honest, whether you realize it or not, you're already dealing with types. Just look at the first 3 errors here. They're all type errors. Types are something that is part of the ECMAScript spec. So it's something that JavaScript already knows about. To emphasize this a little bit more, I want to share a quote. Types exist in JavaScript whether you choose to use tooling which can reason about them for you or not. This is James Henry, who is Microsoft MVP for TypeScript. And I very much agree with this message. If we're having to deal with types already, we may as well use tooling that'll make our lives significantly easier. So before I specifically talk about how TypeScript works and what that introduces to the ecosystem, I do want to acknowledge that it isn't the only project that has tried to introduce static typing to JavaScript. There's also Facebook's Flow. And it worked a little bit differently. It had somewhat better, somewhat more advanced type inference, which is pretty cool. But if you'll recall, in this graph, TypeScript is definitely sneaking up in popularity. And as I'm focusing this talk on how the ecosystem is changing, I'm going to be focusing on that for the rest of the talk. So, TypeScript, what is it? How does it work? So in a nutshell, like I've sort of been alluding to, it introduces static typing to JavaScript. It is what Microsoft calls it as JavaScript that scales. It came about when Microsoft were trying to write larger and larger applications using JavaScript for Windows and for other reasons, and were coming across many different difficulties in the development lifecycle. The syntax is a strict superset of JavaScript. What that means is every single JavaScript file is a syntactically valid TypeScript file, but not the other way around. It is not a replacement to JavaScript. It embraces what JavaScript is and enhances it, enhances the development experience for us. To emphasize that, there are 2 points I want to outline. The first is TypeScript have actually made a bunch of concessions to account for the dynamic nature of JavaScript. So it is what's called an unsound type system. Lots of people that if you have developed in any other static typing or statically typed language, you might be used to a few more guarantees and a bit more information and stuff like that you won't actually get with TypeScript because they had to make some concessions. And the other thing is TypeScript closely tracks the ECMAScript standard. So any new features that are going to get introduced to JavaScript are also introduced to TypeScript. They're often implemented well before the spec is finalized to be ahead of the curve. And the other core thing about TypeScript is it introduces lots and lots and lots of tooling to make our lives so much more easier. So there's really good IDE integration. You can do stuff like jump to definition. You have IntelliSense autocompletion, so you can start writing code and then immediately get suggestions that aren't just what might be correct, but that are guaranteed to be correct. There's, of course, error detection, making sure that you're referencing the things right. You have the type checking everywhere. And there are tools to make refactoring easily. You can move files or move functions or move elements around to different files, and then all the imports and all the resolution is automatically changed in all the files that reference that code, which is super powerful. And if your development team perhaps has a bunch of developers that are using editors that might not have good TypeScript integration, that's perfectly fine. They can still benefit from it. All of these type checking tools can be run in the command line. And of course, you can integrate it with CI/CD. It's just the same as you would with any linting or any unit testing framework. A lot of the information in this slide in particular comes from James Henry's talk, TypeScript State of the Union, which I would highly recommend if you're new to the TypeScript world, you read up or you watch. It's a very good talk. So that might sound like scary, quite a scary proposition, adopting TypeScript. You might be thinking, oh God, I'll need to change all my files, change my build system, etc. I do also want to make you aware of TypeScript's ability to actually do type checking within JavaScript files itself. So you don't necessarily need to fully buy in to the TypeScript world. You can dip your toes in, so to speak, by having some level of type checking within existing JavaScript files. You can either use this tscheck comment to check specific files, or you can use a command line flag that tells TypeScript to check everything. And it will use js.comments to infer the types of parameters and arguments and stuff like that. So if you're unsure, this might be a good thing to explore to sort of convince yourself that it might be worthwhile investing in. So let's look at we'll go back to the old code example and see what it would look like if we converted it all to TypeScript. So the first thing you'll notice here is that all the file extensions are now .ts rather than .js. Beyond that, it might be a little hard to see what the difference is, so I'll highlight them. So I would say that's not that many changes, but I'll outline them and explain what I've done here. So the majority of the changes are in the broadcaster class. Now, has anyone in the room, raise your hand if you're familiar with a programming language that has generic types? Cool, great. So I won't explain that too hard. We've introduced a type parameter T for broadcaster because broadcaster is being used in many different contexts, and we don't really know within the context of just writing this class itself what it will be used with, so we want it to be used with potentially anything. The broadcast message function requires that the message be the same type, be of type T. The add listener function takes a function that accepts a message and doesn't return anything interesting. And then the listeners property is basically a list of those functions. Then the only other thing we have here is the property, we specify when we use the broadcaster in the notifications code that we expect types that have a foo property of type string. So I'm going to give you a quick demo and show you what that looks like when we try and make the same mistakes as earlier. So here I am in VS Code, which unsurprisingly has really good TypeScript support. The TypeScript team and the VS Code team work very closely together, and VS Code is actually written in TypeScript. So let's say I go here and I want to change the broadcast message to send message. You can see immediately on the right here, this has been underlined in red. TypeScript knows that I've made a mistake here, and I can go ahead and resolve it. Perfect. I haven't even had to save the file. It just knows. So I'll undo those changes. Say I wanted a couple of other calls, but I might make a mistake. So I'll do notifications.broadcast message. And you'll notice as I'm typing here, I'm immediately getting suggestions as to what I can write. So I'll do broadcast message, and I'm going to say boo. Oh, that's not correct. So maybe I'll change foo. Great, that works. And then if I forget to give a parameter, as you probably expect, it says the call is incorrect. If I hover over it, it says expected 1 argument, but I got 0. Cool, that's working as expected, saving us from trouble there. And then if I refer to the wrong argument here, oops, it of course highlights that. Then say, for example, I wanted to actually introduce a new property for all notifications. I could go ahead and change the type here. So I want boo to be a number. Scroll down, say this particular call is incorrect because I'm missing a property. I can hover over it and it'll say property boo is missing. So I can type boo and give a number. And then if I go down here, I can do console, not confirm, console.log. If anyone has ever tried to type on a keyboard that's on a lectern, it's a very weird angle. I could do m.boo, and it's automatically suggesting that I do boo. Beyond that, you can also, any JS doc or TS doc that you add to type annotations get immediately available and used in IDE. So if, for example, I were to label this as, and I hover over fboo here, I can have the documentation readily available right from the get-go, even though these files are in completely disparate parts of the code base. And of course, if I hover over boo when I'm declaring it, it's available there as well. And I think that's basically everything I wanted to cover in this demo. So I'll go back. So you might be thinking, if you're not convinced yet, that, I mean, those all look like pretty minor things. Does it actually make a big difference? Does it actually help my development process? Well, Airbnb seemed to think so. In a presentation about migrating to TypeScript, they said for one particular code base that they moved from JavaScript to TypeScript, they discovered that about 38% of the bugs that they were encountering would have been entirely prevented if they were using TypeScript. And I'm also going to speak from personal experience. So you remember at the start of the slide, I was talking a little bit about LGTM. So about 4 years ago, we were in the process of completely redoing all of our front-end code. And we needed to make decisions as to what stack we were going to use, what technologies we were going to use. And we were facing quite a tight deadline as well. We needed to produce things really quickly. And we made the decision to just redo everything in TypeScript from the start. And to aid in that, we also, so our backend was all written in Java, and we created a library that used reflection to automatically create a TypeScript API with types to interact with our backend so that we had type checking all the way from the Java code, basically all the way from the database right to the view code. We make a single change in Java, there would be compilation errors until we resolved it right the way through to the code that actually displayed it to the user, which was super useful. There were about 5 to 6 of us working on it at any one time, and we were all working on different parts of the code base and like producing new page after new page after new page. And we found that we encountered far, far fewer errors in the client side than when we'd written the previous version that was in plain JavaScript. Really, the biggest thing it gave us was it sped up our development process so much, maybe 4 to 5 times as much. We, of course, still got bugs, still got errors. Type checking doesn't prevent errors from occurring, but it definitely sped up our process. And also, I do want to mention that personally, it's now the primary language that I've chosen to adopt pretty much every personal project I work on. I used to use a number of different languages depending on the context. I would use Bash for small scripts, Python for medium-sized projects, Java for larger projects, and then JavaScript when I had to do client-side browser code. And I just now use TypeScript for all of those, even the small Bash scripts. The benefits I get right from the start, even with small code bases, has made developing for me like much more pleasurable. I look forward again to like going home and working on that project. I'm like, oh, I can just write this out, and it just speeds up the process. So that's all well and good. You might be now convinced to use TypeScript for your own project. However, your project might depend on a bunch of NPM modules that are just written in JavaScript. You might have dependencies that use that are written in JavaScript. They don't have any type information. How do you go about actually using them? Because TypeScript will, of course, complain if it doesn't know what it is that you are referring to. So I'm going to give a second demo here real quick to show you how you can fix that. So I'm importing Lodash here. Let's go ahead and create a new file, which is going to be a declarations file, which will contain type information for us. I'll call it Lodash. Declaring a module here, like so. So I've now effectively told TypeScript that this module exists. And if I go back to the application, it's like, cool, there's no error now. However, this doesn't really give us that much. We still have type checking within our application, but we aren't really checking whether we're actually using the module correctly. We've just said to the TypeScript, don't worry about this module, don't worry about how we're using it, just let us use it. And if I hover over these different variables here, you'll see that TypeScript's saying, oh, the type is any, I don't know what it is. This isn't particularly useful. So what you can do instead is, as you're starting to use the library, you can start declaring the actual methods you actually care about as you go along. So we're using the head method there, so I'm going to declare that. So do function head. It's a general purpose. It works over lists of any type, so I'm going to use generics here. And the list is a list of t, and it either returns t or undefined. Cool. So it's a function that takes a list of t, returns either t or undefined if the list is empty. I go back to the application here. We can see actually that we have an error here, and oh, it's because we've actually mistyped head. So I'll go ahead and fix that. And we didn't know that before we actually had the type checking for this function, and it might not be easy to see at a glance. So I'll just go ahead and correct that. Now, if we hover over the types here, it says, oh, result 1 is either going to be a number or undefined because we gave it a list of numbers. And then result 2 is undefined because the list is empty. It can't infer what the type of the list is, so it's nothing. So the only option is undefined. Great. We now have type checking for the library, and we can start, as we're using more of the library, introducing types that make sure that we use it uniformly across our code base. So to recap that small segment, we want to use NPM modules in our TypeScript projects, just like we do with our JavaScript projects. Most NPM modules are still just written in JavaScript, so they don't really have type information. But we can create type definitions for each NPM module that we use. However, you may have realized that that's not particularly efficient. That'll result in lots of duplicate effort across all of the TypeScript projects that want to use particular modules, or at least lots of copying and pasting, which is no good either because they won't be kept up to date as the library changes, etc., or as bugs are found in the type definitions. So there is a solution to that. This project called DefinitelyTyped. Now, DefinitelyTyped is, I believe, the most contributed to project on GitHub. It has over 9,000 contributors, not contributions, contributors, 9,000 individuals that have contributed code to this project. And it's effectively a repository of type definitions for a whole bunch of NPM modules. What the DefinitelyTyped project does is it publishes a package on NPM for every single package that there are types for in this repository. And they're made available at the @types organization on NPM. So if I wanted to get the types for Lodash, it's a widely used project, so unsurprisingly, there are type definitions in DefinitelyTyped. I can simply run this command to get that. So I'll give you a quick demo of what that looks like as well. So same project. This time I haven't got the type definitions again. And in my terminal, I'll just run npm install types Lodash. Good, the internet's working. And you can see immediately that the errors disappeared. And this code is highlighted as wrong because there's the same typo there. Great, hover over that. that's a number or undefined. Hover over this, that's undefined. But what we're also getting as well, if you hover over the actual function itself, is we get all the documentation that was added to those type definitions by the person that created the type definitions. So we're getting much more richer information that's being kept up to date by the community about this library that we can use right from our editor without having to really search anything. So that's all well and good, but that still requires additional effort. It's not just working outside of the box. Shouldn't there be a way that a library that we install comes along with type definitions as well as the code that's actually being run? Well, yes, and that's possible. In your package.json file, along with specifying a main module, you can also specify types that represent that main module. And what TypeScript will do is it'll realize that the types exist for this particular package that you've installed in Node modules and immediately make them usable without having to install a specific @types package as well. So final demo. This is a library that I've written to control stage lighting. You'll recall that I have that as a passion. So I actually haven't installed the npm module itself yet that it refers to, so this code wouldn't work. That'd be an import error. But if I do npm install as soon as the project light desk, the error immediately disappears because not only has it installed the npm module with JavaScript code, it's actually got the type definitions bundled with it as well. And I can hover over different elements. I've forgotten which of this I've actually documented. Okay, apparently none of it. But any type, any TS doc I've got on the library itself will also be made available. So that's cool. You can, as an author of a JavaScript library, create some JavaScript code and create type definition to go along with it to help your users. But that might still require a lot of manual work, updating at least the type definitions within your repository alongside the JavaScript code. So I would highly recommend, if you're writing an npm project, write it in TypeScript to begin with so that you can automatically get the type declarations created for you, and it will save you a lot of work. So this is the world I hope for. I would like to see as much JavaScript code as possible being migrated over to TypeScript code. It offers so much more assurances, both within the project and for any TypeScript users that are using your project, and really, I believe, is going to make the JavaScript ecosystem much more healthy. Yeah, I think that's about it. We have some time for questions, but I'll give you a quick summary before I'm done. So TypeScript makes it easier to write JavaScript applications at scale by introducing static typing, which catches many common mistakes. It adds lots of tooling, like autocomplete jump to definition, refactoring tools that make things a lot easier. If we want to use npm modules in our TypeScript projects, we need to have type definitions for those, because otherwise we're not going to get those guarantees all the way through our dependencies. DefinitelyTyped is a project that is working to create type definitions for many of those packages. And they're all made available as @types packages on npm. And more npm packages are starting to bundle types, which is great. And more of those projects as well are starting to migrate to TypeScript to reduce the work and get all of the benefits of TypeScript. Yeah, that's about it. Oh, which of course manually removes the effort needed to keep type definitions in the code in sync. I'd like to remind you to rate the session. All speakers are being asked to remind their attendees to do this. It helps the speakers, it helps O'Reilly. I will be making all of these slides available online, and I'll leave a comment in the session so that you can follow that. And yeah, that's about it. I have a follow-up talk at 2:35 in Portland 252, and that'll be a live coding presentation where I will be building a npm library from scratch using TypeScript that automatically bundles type definitions. So you can, I would love it for you to come to that. I also have been given a bunch of TypeScript stickers by the Microsoft booth. So if you like stickers, come see me. And of course, don't forget to rate the session. So yeah, we have 5 minutes left. So I welcome any questions that people might have. Yes?
It's perhaps not a question, but a remark. I learned TypeScript by developing VS Code plugins, extensions. And we're all in-house, and they are very specific to our own shop, but okay, that's it. Now, if you try to make VS Code extensions, you have to rely on the Microsoft API for VS Code. And okay, it is documented, but not really well. And when you use TypeScript, I learned that you start to think very much in depth at what you are doing. Instead of when you are working with JavaScript, you just do things, and most of the time they work.
Yeah.
With TypeScript, they don't work, and you have to really go into the thing in depth before you have something to show for your work. And I think that's a very, very big advantage. Your code is just better in quality.
Yeah, no, working with TypeScript libraries that force you to think about fixing errors when you come up with type errors definitely do make you think a little bit more about the code you're writing, and definitely, I think, advances your development skills totally. Yes?
So I'm just a dumb back-end engineer with a stupid question.
Okay.
Okay, so you were writing in files with an extension of .ts.
Yes.
And I only know about running, my website runs .js files, then I put them out in the static.
Yes.
Is there an interpreter for TypeScript, or is
there's a compiler. Yeah. Most browsers don't have TypeScript support, so you do have to have a compilation step that converts the JavaScript to TypeScript. Yeah. Sorry, other way around. It converts the TypeScript to JavaScript. Yeah. Yes.
Would you venture to take a swag at how long it takes to incorporate TypeScript into an existing JavaScript SK, like let's say 100,000 line code, back that with like a few hundred sentences?
It depends on how much time you want to put into it. You can take it as fast or as slow as you want. You could do a sprint session where you maybe spend 1 month completely focusing on integrating TypeScript. The important thing to know is that you can really do it gradually. TypeScript has many different options to relax a lot of the checks for the compiler so that you can be a lot less strict to begin with and increase strictness and increase how harsh it is as you go along. And that's generally the approach you might take. You can keep some of your files in JavaScript, some of them in TypeScript, start moving some things over, and over time, incorporate strictness. Unsurprisingly, with any new project, will start with TypeScript at the maximum strictness. But yeah, it's really up to you. Yes?
Have you run into any issues like debugging errors in a browser, like in reconciling that with TypeScript?
On some occasions, there are the types can sometimes obscure some things that are going on. If I maybe have typed things incorrectly, or I've convinced TypeScript that something is of a type that it might not be, there are certainly cases where you need to you realize that some type annotations are incorrect. However, the amount of time that I'm debugging errors like that versus the amount of time it saves is uncomparable. Right. Yeah. So when you're debugging in the browser, TypeScript can emit a mapping file that allows you to, as you're stepping through code, it will actually show you the TypeScript code that compiled the JavaScript code that you're looking at, rather than the JavaScript code itself. Yes.
You're advocating putting the TypeScript out in your npm packages that you're posting, but
yes.
But you have potential version issues in terms of the JavaScript for people that want to be able to adopt that code, right? How does that play out? When you publish npm packages, you're not actually publishing the TS files. You're publishing the exported JavaScript files along with type definitions. So anyone that's still using just plain JavaScript will be able to use the module as normal. Yeah, I'll be covering that a lot more in my other talk later today. Yeah. Yes.
Has writing unit tests got easier for me because of using TypeScript? I would say that every bit of code I've written has got easier. Writing unit tests, of course, I get a bunch of autocompletion when I'm defining the individual tests, which speeds up the process. I'm less likely to write tests that aren't really doing anything of value. One thing I do want to note, though, is there is a misnomer that unit testing, or at least 100% coverage with unit testing, will catch everything that static typing does, and that is demonstrably false. I have a bunch of like 6-line examples that I can show that where 100% coverage passes, but there are type errors that'll happen in runtime. But I won't go too much into detail. And I think that's about all I have time for. If you want stickers, come see me. Please come see my other talk. Please come rate my talk. Thank you.